Hello, in this lecture we will find the size of angle x in two different methods. In the drawing we have quadrilateral SRPQ, and we know that side SP is equal to side SQ, and we also know that angle SRP, this angle, is equal to 65 degrees, and angle PRS is equal to 50 degrees. And we want to find out the size of angle PSQ that equals to x. So we will start with the first method. So in the first method we will do a construction. We will extend side QR by a straight line, and then from point S we will draw perpendicular to the extended QR side. So here this angle equals to 90 degrees. It is a right angle. We will define the touching point between the perpendicular from point S to the extended QR side as point N, and then we will draw perpendicular from point S to side PR. So actually this angle is a right angle, it equals to 90 degrees, and also this angle is a right angle that equals to 90 degrees. We will define the touching point between the perpendicular from point S to PR as point N. Again, the touching point between the perpendicular to side PR is defined as point N. So actually we know that QR is the side of quadrilateral SRQP, that is to say it is a straight line, and then we extended this straight line QR by a straight line RN. So actually QN is a straight line because it composed from a straight line that extended by a straight line, so QN remains a straight line. So I write it down. QN is a straight line, and we have a rule that states that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, I write it down. The rule states that the sum of the angles on one side of a straight line is equal to 180 degrees. The sum of the angles on one side of a straight line is equal to 180 degrees. So that is to say, if we look on the straight line QN or NQ from this side of the straight line QN, the sum of the angles at point R must be equal to 180 degrees. So if you focus on this side of the straight line NQ at point R, the sum of the angles must be equal to 180 degrees. That is to say, 50 degrees plus 65 degrees plus the size of this angle that we will define as angle Z must be equal to 180 degrees according to this rule that I read. Okay, so here we will subtract we will subtract 50 degrees from this equality, and we will get that 65 degrees plus angle Z equals to 130 degrees. Here we will subtract 65 degrees from this equality, and we will get that angle Z equals to 180 degrees minus 65 degrees is 65 degrees. So we found out that the size of angle Z is 65 degrees, so we can write here that angle Z equals to 65 degrees. Okay? So in the next step we will focus on the right triangle SRM, the right ring triangle SMR, and we will also focus on the right triangle SNR, the blue right triangle SNR. And we will actually prove that the green triangle congruent to the blue triangle. Okay, so we will focus on triangles SRN, the green triangle, the right green triangle SRN, and the blue green right triangle, the blue triangle, the blue right triangle, the blue right triangle, triangle SNR. The blue right triangle, triangle SNR. And we will prove that the green triangle is congruent to the blue triangle. Again, we will focus on triangles SRN and triangle SNR, the green and the blue triangle. Actually, first of all, we have a common side, SR is a common side. It belongs both to the green triangle and also to the blue triangle. So you can write down that SR equals to SR as a common side. Okay, SR equals to SR. It is a common side that belongs to both triangles. And we also know that those two angles are equal to each other. They are both equal to 65 degrees. That is to say, angle MRS of the green triangle is equal to angle NRS of the blue triangle, and both angles are equal to 65 degrees. I'll repeat again. Angle MRS is equal to angle NRS, and both angles are equal to 65 degrees. And the third angle, actually those two angles are both right angles and they are equal to each other. They are actually equal to 90 degrees. So angle SMR in the green triangle is equal to angle NSR in the blue triangle. Angle SNR in the blue triangle, and both angles are equal to 90 degrees. Okay, angle SMR is equal to angle SNR, and both angles are equal to 90 degrees. So we actually have the rule that the sum of the angles in any triangle is equal to 180 degrees. So therefore, if we know that in a triangle two angles are equal to 90 degrees and 65 degrees, in total the sum of them is 155 degrees. So the third angle must be equal to 180 degrees minus 155 degrees in order to complete the sum of the angles in the triangle to 180 degrees. So we can write down that the third angle, both in the green triangle and also in the blue triangle, that is actually angle SMR in the green triangle, angle MSR in the green triangle, that will be equal to angle NSR in the blue triangle, and they both will be equal to 180 degrees minus 155 degrees. Again, the third angle, angle MSR in the green triangle and angle NSR in the blue triangle, must be equal to 180 degrees minus 155 degrees. That is actually 25 degrees. Okay? So what is important here that those two angles are equal to each other. Okay, so we actually found out that the three angles of the green triangle are correspondingly equal to the three angles of the blue triangle. Okay, so therefore, and we also have a common side that belongs to both triangles. So we actually proved that the green triangle is congruent to the blue triangle. That is to say, triangle SMR, the green triangle SMR, is congruent. That is the sign of congruent. Is congruent to triangle SNR, the blue triangle, according to angle side angle rule. Angle side angle rule. Actually, we proved that all the angles of the green triangle are equal to all the angles of the blue triangle, even more than we needed. It is more than we needed because it is enough to prove that those two angles and the side that attach to those two angles, that is to say SR in the green triangle, are corresponding equal to those two angles and the side that attach to those two angles in the blue triangle. But we even proved more than what we need. That we proved that all the angles of the green triangle are corresponding equal to all the angles of the blue triangle. So therefore the green, and we also have the common side SR. So we actually proved that the green triangle can go into the blue triangle according to angle side angle rule. So what is angle side angle rule? If you prove that two angles and the side that attach to those two angles are corresponding equal to two angles and the side that attach, if you prove that two angles and the side that attached to two angles in one triangle is corresponding equal to two angles and the side that attach to those two angles in another triangle, then you actually proved that those two triangles are congruent to each other according to angle side angle rule. Okay? So from the fact that the green triangle congruent to the blue triangle, we can conclude that side SM of the green triangle is equal to side SN of the blue triangle according to the rule that states that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the two corresponding sides, that is to say SM and SN, will be equal to each other. So we can write down that from the fact that the two triangles congruent to each other, we can conclude that side SM of the green triangle is equal to side SN of the blue triangle. Okay? So in the next step, we will focus on the right triangle, triangle SMP, this triangle, and on the right triangle, triangle SNP, this triangle. And we will actually prove that those two right triangles can go into each other. Okay? So actually we'll focus on this right triangle, triangle SMP, and on this right triangle, triangle SNP, triangle SNP. Again, we will focus on the right triangle, triangle SMP, on the other, and on the other right triangle, triangle SNP, and we will prove that those two right triangles can go into each other. Okay, so first of all, we proved that SM is equal to SN. Okay, we have already proved just right now that SM is equal to SN. SM in the green triangle, in degree triangle, triangle SMP is equal to Sn in the Sm in triangle SMP is equal to Sn in triangle SNQ. Okay? Again, we proved that Sm in the right triangle, triangle SMP is equal to Sn in the right triangle, triangle SNQ. This triangle, okay? And so here we know that SP equals to SQ according to what is given us in the question. SP equals to SQ, so we will define SP as Y, and then SQ will be also equal to Y. That is according to our definition. So we know that SP in the right triangle, triangle SMP equals to SQ in the right triangle, triangle SNQ. And both those sides are equal to Y according to our definition. Okay, so SP is equal to SQ, and both those two sides are equal to Y according to our definition. And the third side, side PM, is equal to side NQ. Side PM from triangle, the right triangle, triangle SMP is equal to side NQ in the right triangle SNQ. Actually, we will prove that those two sides are equal to each other. We will prove that side PM on the right triangle SMP is equal to side NQ on the right triangle SNQ. So, because of the fact that those two right triangles, that those two triangles are right triangles, we can implement the Pythagorean theorem in those two right triangles. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So, here in the right triangle, triangle SMP, according to the Pythagoras theorem, I write it, that is according to the Pythagoras, I write it, that is according to the Pythagoras theorem. According to the Pythagoras theorem, in the right triangle, triangle SMP, SM square plus PM square SM square plus PM square is equal to SP square, that is the hypotenuse square, SP square. Again, in the right triangle, triangle SMP, according to the Pythagoras theorem, SM square plus PM square equals to SP square. Here, we will subtract SM square from this equality, and we will get that PM square is equal to SP square minus SM square. So here we will take a root out of this equality, and we will get that PM equals to the root of SP square minus SM square. Okay, we found out that PM equals to the root of SP square minus SM square. Okay, so in the next step we will focus on the right triangle, triangle SNQ. On the right triangle, triangle SNQ, we know that according to the Pythagoras theorem, Sn squared plus Nq squared will be equal to Sq squared. Sn squared in the right triangle, triangle SNQ, according to the Pythagoras theorem, Sn squared plus Nq squared equals to Sq squared. I will repeat again. In the right triangle, triangle SNQ, according to the Pythagoras theorem, Sn squared plus Nq squared equals to Sq squared. Here we will subtract Sn squared from this equality, and we will get that Nq squared is equal to Sq squared minus Sn squared. So here we will take a root out of this equality, and we will get that Nq is equal to the root of Sn, the root of Sq squared minus Sn squared. That is the value of Nq according to the Pythagoras theorem. And we have already found out that Pm equals to the root of Sp squared minus Sm squared. Actually, this expression is equal to this expression. I will write it, the root of Sq squared minus Sn squared. It is actually equal to the root of Sp squared minus Sm squared. Actually, those two expressions are equal to each other. Why those two expressions are equal to each other? Because of the fact that Sq is equal to Sp, according to what is given us in the question. Sq is equal to Sp, and we define both of them as y, so they are equal to each other. And also Sn is equal to Sm. Sn is equal to Sm. Here Sn is equal to Sm, we already proved it. So again, Sq is equal to Sp and Sm is equal to Sn. So we found out that those two expressions are equal to each other. That is to say, Nq is equal to Pm, or Pm equals to Nq. So we found out that Pm is equal to Nq. Okay? So we actually proved that triangle, the right triangle, triangle SMQ, SMP, the right triangle, triangle SMP, this triangle is congruent to the right triangle, triangle SNQ. This is the sign of congruent, SNQ. So the right triangle, triangle SNP is congruent to the right triangle, triangle SNQ according to side rule. What is side rule? We actually proved that the three sides of the right triangle, triangle SNP is correspondingly equal to the three sides of the right triangle SNQ. Therefore, we proved that those two triangles can go into each other according to side rule. So from the fact that those two right triangles can go into each other, those two right triangles can go into each other, we can conclude that those two angles are equal to each other according to the rule that states that corresponding angles in congruent triangles are equal to each other. Those two right triangles can go into each other, therefore those corresponding angles will be equal to each other. So actually we can write down that angle SMP in triangle SMP is equal to angle SNQ to angle SPM. Angle SPM, this angle in triangle SPM is equal to angle NQS in triangle SNQ according to the rule that corresponding angles in congruent triangles are equal to each other. And if we define angle SPM as theta, then angle SQN will be also equal to theta because of the fact that those two angles are equal to each other. So we actually found out that angle SPM equals to angle NQS, and both angles are equal to theta. Okay? So in the next step, I will present to you a new rule, and we will implement that new rule in our drawing. So it is actually will be rule number 2. Rule number 2 states that if a segment line subtends two equal angles on the same side, then the quadrilateral is inscribed by a circle and the 4 points lie on that circle. I will read rule number 2 again. Rule number 2 states that if a segment line subtends two equal angles on the same side, then the quadrilateral is inscribed by a circle and the 4 points lie on that circle. So actually we can implement this rule in our drawing, because in our drawing we have two equal angles. That is to say, both those angles are equal to theta, and both those two angles subtend on the same segment line SR. Therefore, according to rule number 2 that I just right now read, the quadrilateral SRPQ is inscribed by a circle, and the 4 points SR, P and Q lie on that circle. So actually here we have the same quadrilateral SRPQ. We can see here that those two angles that both equal to theta, they subtend on the same segment line SR. Therefore, the quadrilateral SRPQ is inscribed by a circle. As you can see, the red circle inscribes the quadrilateral SRPQ is inscribed by the red circle, and the 4 points SR, P and Q lie on that circle, lie on the red circle. Okay, again, this drawing is the implementation of rule number 2 in our circle. We have here two angles that subtend on the same segment line SR. Therefore, according to rule number 2, the quadrilateral SRPQ is inscribed by a circle, the red circle, and the 4 points SRPQ lie on this red circle. Okay, and so we have also rule number 3, and rule number 3 states that peripheral angles that subtend on the same chord are equal to each other. I write it down. Peripheral angles that subtend on the same chord are equal to each other. So I read rule number 3 again. Rule number 3 states that peripheral angles that subtend on the same chord are equal to each other. Again, we can implement rule number 3 in our drawing. Here in our drawing we have peripheral angle X that subtend on chord PQ, and we have also peripheral angle PRQ that equals to 50 degrees that subtend on the same chord PQ. Therefore, according to rule number 2, peripheral angles that subtend on the same chord are equal to each other. Those two peripheral angles subtend on the same chord PQ, therefore they are equal to each other. That is to say, x equals to 50 degrees. Okay, x equals to 50 degrees according to rule number 2. We found out that x equals to 50 degrees according to rule number 2 because of the fact that those two peripheral angles subtend on the same chord PQ. Therefore, according to rule number 2, they are equal to each other. That is to say, x equals to 50 degrees. So we finished with the first method. In the next step, we'll find out the size of angle x according to a second method. So, in the second method, we will do another construction. We will actually extend side SR of triangle SR PQ by a straight line. We extended side SR of triangle we extended side SR of quadrilateral SRPQ by a straight line. Then from point Q we will raise perpendicular to the extended SR. So this angle equals to 90 degrees. And we will define the touching point between the perpendicular from point Q to the extended SR as point M. In the next step, we will extend the perpendicular QM in such a way that Q dash M will be equal to QM. We extended the perpendicular QM until Q dash M equals to QM. Okay, Q dash M is equal to QM according to our construction. Then in the next step we will join together points R and Q dash by a straight line. Again, we join together points R and Q dash by a straight line. And then we will also join together points S and Q dash by a straight line. As I've already told you, SR is one side of quadrilateral SRPQ. This quadrilateral, therefore it is obviously a straight line, and after we extended this the straight line SR by a straight line, it remains a straight line. So SM is a straight line. Okay, SM is a straight line. Well, I write it down that SM is a straight line. And we have rule number 1 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. That is to say, if we look on the bottom side of the straight line SM at point R, the sum of the angles must be equal to 180 degrees. That is to say, 65 degrees plus 50 degrees plus the size of this angle that we will define as angle Z must be equal to 180 degrees according to rule number 1. Okay, 65 degrees plus 50 degrees plus the size of angle Z must be equal to 180 degrees according to rule number 1. That I mentioned in the first method. Okay, so here we'll subtract 50 degrees from this equality and we'll get it 65 degrees plus the size of angle Z equals to 180 degrees minus 50 degrees is 130 degrees. Here we'll subtract 65 degrees from this equality and we'll get that angle Z equals to 130 degrees minus 65 degrees is 65 degrees. So we found out that the size of angle Z is actually 65 degrees. So we can write here that this angle QRM equals to 65 degrees according to rule number 1. This angle equals to 65 degrees. Okay, so we will actually also, we know that QM is perpendicular to the extended SR. QM is perpendicular to SM. So QM as perpendicular is a straight line. Then we extended the straight line QM by a straight line. So it remains straight lines. That is to say, QQ dash is a straight line. Okay, QQ dash is a straight line. QQ dash is a straight line, and we will use rule number 1 in order to find out the value of this angle. This angle we define as angle L, and we know that the sum of the angles on this side of the straight line QQ dash at point M must be equal to 180 degrees according to rule number 1. That is to say, 90 degrees plus the size of angle L must be equal to 180 degrees according to rule number 1. So here we will subtract 90 degrees from this equality and we'll get that the size of angle L is actually 90 degrees. That is to say, angle L is a right angle. Angle L is a right angle. That is to say, it equals to 90 degrees. So in the next step, we will focus on the right triangle QMR, and on the right triangle Q dash MR. Okay, we'll focus on the right triangles QMR and Q dash MR. Okay, and we will actually prove that those two right triangles can go into each other. Okay, we'll focus on triangles QMR and the right triangle Q dash MR. Again, we will actually prove that the right triangle QMR is congruent to the right triangle Q dash MR. Okay, so first of all, we know that QM equals to Q dash M according to our construction. Again, QM is equal to Q dash M. That is according to our construction. QM is equal to Q dash M according to our construction. We also know that those two angles are equal to each other and they are both right angles. So actually angle QMR equals to angle Q dash MR. And both angles are equal to 90 degrees. Okay, angle QMR equals to angle Q dash MR and both angles are equal to 90 degrees. And also we have here a common side. RM is a common side that belongs to both triangles. So we can write down that RM equals to RM is a common side. RM equals to RM is a common side that belongs to both triangles. So we actually, RM equals to RM is a common side, so we actually proved that the right triangle QMR is congruent to the right triangle Q dash MR according to side angle side rule. So I write it down. We proved that the right triangle QMR is congruent. Again, this is the sign of congruent to the right triangle Q dash MR according to side angle side rule. Okay, so what is side angle side rule? If you prove, here we proved that two sides and the angle between them in triangle Q dash MR are correspondingly equal to two sides and the angle between them on triangle QMR. Therefore, we proved that those two triangles can congruent to each other according to side angle side rule. Okay, so from the fact that those two triangles can congruent to each other, we can conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. So if angle QRM is equal to 65 degrees, then angle Q dash RM will be also equal to 65 degrees. Again, according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore those corresponding angles will be equal to each other. So I'm writing down angle QRM in triangle QRM is equal to angle Q dash RM and both angles are equal to 65 degrees. That is the first thing that we can conclude from the fact that those two triangles can go into each other, and the second thing that we can conclude from the fact that those two triangles can go into each other, that QR or RQ is equal to RQ dash. RQ, side RQ of triangle QRM is equal to side RQ dash, according to the rule that corresponding sides in congruent triangle and congruent triangles are equal to each other. Those two triangles can go into each other, therefore those two corresponding sides will be also equal to each other. Okay, so here we actually know that SP equals to SQ according to what is given us in the question. SP equals to SQ, so we'll define SP SY, SP equals to Y according to our definition. Therefore, SQ will be also equal to Y because of the fact that those two sides are equal to each other. Okay, so in the next step, we will focus on the right big triangle, triangle QMR, and on the other right big triangle, triangle QDesMR. And we will actually prove that those two right big triangles can go into each other. So we will focus on the right big triangle, triangle QMS. The right big triangle is actually triangle QMS. And the other right big triangle is actually QDesMS, this triangle, QDesMS. Okay, so we will actually prove that the right big triangle QMS is congruent to the right big triangle QDesMS. QDesMS. Okay. So first of all, we know that QM equals to QDesM according to our construction. QM is equal to QDesM according to our construction. Again, QM equals to QDesM according to our construction. And we also know that those two angles are also equal to each other. They are both equal to 90 degrees. So actually angle QMS in triangle QMS is equal to angle QDesMS in triangle QDesMS. QDesMS, and both those angles are equal to 90 degrees. I will repeat again, angle QMS is equal to angle QDesMS, and both those two angles are equal to 90 degrees. And we also have here a common side. SM is a common side, it belongs to both triangles. So we can write down that SM equals to SM as a common side that belongs to both triangles. Okay, SM equals to SM as a common side. So we actually proved that the three sides of the right big triangle QMS, this triangle, are corresponding equal to three sides of the right big triangle QDesMS, this triangle. So we actually proved that the right big triangle QMS is congruent to the right big triangle QDesMS. I repeat again, we actually proved that the right big triangle QMS is congruent to the right big triangle QDS according to side rule. According to side rule. So, according to side rule, so what is side rule? Actually, if you prove that three sides of one triangle are correspondingly equal to three sides of other right triangles, if you prove that three sides of one triangle are correspondingly equal to three sides of the other triangle, then you actually prove that those two triangles can go to each other according to side rule. And we proved that three sides of this right triangle are correspondingly equal to three sides of this right triangle. Therefore, we prove that those two triangles can go into each other according to side rule. So from the fact that those two triangles can go into each other, we will conclude that SQ equals to SQ dash. Again, we will conclude that SQ is equal to SQ dash according to the rule that corresponding sides in congruent triangles are equal to each other. Actually, those two triangles can go into each other, therefore those two corresponding sides will be also equal to each other. And if SQ equals to Y, then SQ dash will be also equal to Y because of the fact that those two sides are equal to each other. Okay, so SQ equals to SQ dash. Both sides are equal to Y according to our definition. Again, SQ equals to SQ dash, and both those two sides are equal to Y according to the rule that corresponding sides in congruent triangles are equal to each other. Okay, so in the next step, we will focus on the triangle SRQ and on triangle SRQ dash, and we will prove that those two triangles can go into each other. So we will focus on triangles SRQ and triangle SRQ dash. Again, we will prove that triangle SRQ is congruent to triangle SRQ dash. Okay, so first of all, we know that we've already proved that the QR equals to, or RQ equals to RQ dash. We have already proved that RQ equals to RQ dash. RQ equals to RQ dash, and we just right now proved that SQ equals to SQ dash. SQ equals to SQ dash. Okay, we just right now proved that SQ equals to SQ dash, and we have also a common side. SR is a common side, it belongs to both triangles, so we can write down that SR equals to SR is a common side. So SR equals to SR is a common side. So we actually proved that three sides of triangle SRQ are correspondingly equal to three sides of triangle SRQ dash. This triangle. Therefore, we actually proved that triangle SRQ is congruent to triangle SRQ dash according to side rule. So I write it down. Triangle SRQ congruent to triangle SRQ dash according to side rule. Okay, all the sides of triangle SRQ are correspondingly equal to all the sides of triangle SRQ. Therefore, those two triangles can go into each other according to side rule. From the fact that those two triangles can go into each other, we can conclude that those two angles are equal to each other. That is to say, angle RQS, this angle is equal to angle RQ-S. Angle RQS is equal to angle RQ-S according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore those two corresponding angles will be also equal to each other. So those two angles are equal to each other. And if we define one angle as theta, then the other angle will be also equal to theta because of the fact that those two angles are equal to each other. Okay, so angle RQS is equal to angle RQ-S, and both angles are equal to theta according to our definition. So actually, in the next step, we will prove that PQ-, line segment PQ- is a straight line. Okay. So how we can prove that line segment PQ- is a straight line? Actually, if we prove that angle PRQ-, if we look from the bottom side, that angle PRQ- is angle that equals to 180 degrees, then we actually proved that PQ- is a straight line, because any angle that equals to 180 degrees, it is actually a straight line. Okay, so what is the size of angle PRQ- if we look from the bottom side? The size of angle PRQ- if you look from the bottom side of line segment PQ-, it will be equal to 50 degrees plus 65 degrees plus 65 degrees. 65 degrees plus 65 degrees is 130 degrees, and 130 degrees plus 50 degrees is 180 degrees. So we actually proved that the size of angle PRQ- equals to 180 degrees when we look from the bottom side of line segment PQ-. Because of the fact that angle PRQ- equals to 180 degrees, we can conclude that angle PRQ- is a straight line, because any angle that equals to 180 degrees is a straight line. Okay, so PRQ- is actually a straight line. PRQ- is a straight line because angle PRQ- is a straight line. PRQ- is a straight line, and if PRQ- is a straight line, then PQ- is also a straight line. Okay, so PQ- is also a straight line. So we found out that line segment PQ dash is a straight line. Because of the fact that line segment PQ dash is a straight line, we can conclude that the shape SPQ dash is a triangle. Again, the shape SPQ dash is a triangle. Okay? The shape of QP dash is a triangle. So, in triangle QP, in triangle SPQ dash, in triangle SPQ dash, we have two sides that are equal to each other. That is to say, SP equals to SQ dash equals to Y. SP equals to SQ dash equals to Y. Again, in triangle SPQ dash, we know that triangle has two sides that are equal to each other. That is to say, SP equals to Q dash, and according to our definition, those two sides are equal to Y. And we actually have the rule that in front of equal sides in the triangle, there are equal angles. In front of these two sides that are equal to each other, both of them are equal to Y, we have two equal angles. In front of this side we have, of this side Y, we have this angle, and in front of this side Y, we have this angle. So, according to the rule that I stated, those two angles are equal to each other because they are located in front of equal sides. So we know that this angle equals to theta, so this angle will be also equal to theta because of the fact that those two angles are equal to each other. So we found out that this angle SPQ dash or SPR equal, or SPQ dash is equal to theta. Okay, so we have here two angles that are equal to each other, both angles are equal to theta. So from this step we will continue according to method 1, to the first method. We have here two angles that are equal to each other, and they subtend on the same segment line SR. So according to rule number 2, the quadrilateral SRPQ is inscribed by a circle, and the 4 points SRPQ lie on that circle. Okay, so I'll repeat on rule number 2 again. We know that those two angles that are equal to each other, they're both equal to theta, actually subtend on the same segment line SR. Therefore, according to rule number 2, the quadrilateral SRPQ is inscribed by a circle, and the 4 points SRPQ lie on this circle. As you can see, the 4 points SRPQ lie on this blue circle. Okay? And we have also rule number 2 that I've already mentioned in method 1. Rule number 2 states that peripheral angles that subtend on the same, actually we have here, I didn't complete it, here you can see we have here angle X, and here we have angle that equals to 50 degrees, so I should write those angles in the drawing. And we actually have rule number 2 that states that peripheral angles that subtend on the same peripheral angles that subtend on the same chord are equal to each other. Angle X is a peripheral angle, and angle X subtends on chord PQ. Angle PRQ that equals to 50 degrees subtends on the same chord PQ. Therefore, according to rule number 2, those two peripheral angles that subtend on the same chord PQ are equal to each other. That is to say, X equals to 50 degrees. Okay, so X equals to 50 degrees according to rule number 2, exactly as we did in method 1. X equals to 50 degrees according to rule number 2. Why? Because those two peripheral angles subtend on the same chord PQ, therefore they are equal to each other. That is to say, X equals to 50 degrees. Okay? So we found out that the size of angle X is 50 degrees according to the second method also. So in the next step I will summarize the lecture. So we actually wanted to find out the size of angle X, this angle PSQ, that actually equals to X, and we have here quadrilateral SRPQ, and actually in the first method, in order to find out the size of angle X, we did a construction. Actually, we extended side QR by a straight line, and then from point S we raised perpendicular to the extended QR. So this angle equals to 90 degrees. We defined the touching point with the extended QR and the perpendicular as point N. This angle is 90 degrees. And we also, from point S, we drew perpendicular to PR, and we defined the touching point between the perpendicular to PR as point M. So this angle is 90 degrees, and this angle is 90 degrees because of the fact that SM is perpendicular to PR. So those two angles are 90 degrees. And we actually calculated the size of this angle according to rule number 1. Rule number 1 states that the sum of the angles on one side of a straight line is equal to 180 degrees. So the meaning of rule number 1 that is actually, first of all, we know that QN is a straight line because QR is one side of quadrilateral SRPQ, therefore it is a straight line, and we extended the straight line QR by a straight line. So NQ must be also be a straight line. QN is a straight line, and if we look on the straight line from the bottom side of that straight line, we know that according to rule number 1, if we look only on one side of that straight line, on the bottom side, the sum of the angle at point R will be equal to 180 degrees. That is to say 50 degrees plus 60 degrees plus the size of angle Z plus the size of this angle that we define as Z must be equal to 180 degrees. Okay? If we focus on the bottom side of the straight line NQ at point R, the sum of the angles equals to 180 degrees. Okay, so here we subtracted 50 degrees from this equality, and then we subtracted 65 degrees from this equality, and we found out that angle Z equals to 65 degrees. So this angle equals to 65 degrees. Okay, then we actually focused on the green triangle and the blue triangle. Those two triangles are right triangles, and we actually proved that those two right triangles can go into each other. First of all, we know that SR is a common side, it belongs to both triangles, so we can write down that SR equals to SR. Then we know that those two angles are equal to each other, they both equal to 65 degrees, and we know that those two angles are also equal to each other, they are right angles, and they are both equal to 90 degrees. So, what is the size of the third angle? If we have one angle that equals to 90 degrees and the other angle equals to 65 degrees, so in total the sum of two angles in a triangle, in both triangles, is equal to 155 degrees. So in order to complete the sum of the angles in the triangle to 180 degrees, the third angle must be equal to 25 degrees. So those two angles are both equal to 25 degrees, and they are actually equal to each other. So we actually proved that those two triangles can go into each other according to angle side angle rule. We proved more than we need, because we proved that all the angles in the green triangle are equal to all the angles in the blue triangle, and also we have a common side. So we actually proved that those two triangles can go into each other according to angle side angle rule. So from the fact that those two triangles can go into each other, we can conclude that SM equals to SN, according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, SN equals to SN. Then we focus on those two right triangles, right triangle SMP and the right triangle SNQ. And we also proved that those two right triangles can go into each other. We know that SM equals to SN. We also know that SP equals to SQ, and according to our definition it equals to Y. And we proved that PM is equals to NQ. Why PM is equals to NQ? Because of the fact that we have here two right triangles. So we can use the Pythagorean theorem in order to find out the value of PM. The value of PM, according to the Pythagorean theorem, equals to PM squared equals to PM squared plus SM squared equals to SP squared. The square of the hypotenuse equals to the sum of the squares of the perpendiculars, according to the Pythagorean theorem. We subtracted SM squared from this equality, and we got that PM squared equals to SP squared minus SM squared. We took a root out of this equality, and we got that PM equals to the root of SP squared minus SM squared. In the same way, we calculated the size of NZ according to the Pythagorean theorem. In triangle SNQ, according to the Pythagorean theorem, SN squared plus NQ squared equals to SQ squared. We subtracted NS squared from this equality, and we got that NQ squared equals to SQ squared minus SN squared. We took a root out of this equality, and we got that NQ equals to the root of SQ squared minus SN squared, and we have already found out that PM equals to the root of SP squared minus SM squared. But we know that SQ equals to SP according to what is given as the equation, and we already proved that SN equals to SM. Here SM equals to SN. We have already proved it. Therefore, those two expressions are equal to each other. That is to say, PM equals to NQ. So we actually proved that all the sides of triangle SNQ are corresponding equal to all the sides of triangle SMP. Therefore, those two triangles can go into each other according to side rule. From the fact that those two triangles can go into each other, we concluded that angle MPS equals to angle SQN. Those two angles are equal to each other, and if we define one angle as theta, then the other angle will be also equal to theta. Then we have rule number 2 that states that if a segment line subtends two equal angles on the same sides, then the quadrilateral is inscribed by a circle, and the 4 points lie on that circle. So here we have two angles that are equal to each other, they both equal to theta, and they subtend on the same line segment SR. Therefore, according to rule number 2, the quadrilateral SRPQ is inscribed by a circle, and those 4 points SR, P, and Q lie on that circle. Again, according to rule number 2, because of the fact that those two equal angles lie on the same line segment SR, then the quadrilateral SRPQ is inscribed by this circle, and the 4 points SR, P, and Q lie on this red circle. Then we have rule number 3 that states that peripheral angles that subtend on the same chord are equal to each other. That is to say, we have here two peripheral angles that subtend on the same chord, therefore they are equal to each other. That is to say, x equals to 50 degrees. So this was the first method. Then we actually found out the size of angle x according to a second method. According to the second method, we actually extended side SR until point M, and from point Q we raised perpendicular to the extended SR, so this angle equals to 90 degrees. Then we actually extended QM until Q dash M equals to QM. So Q dash M equals to QM according to our construction. Then we calculated the side. We know that actually SM is a straight line. We extended SR is one side of a quadrilateral, therefore it is a straight line. Then after we extended SR by a straight line, it remains straight line, so SM is a straight line. Therefore, if we look, actually here it is more accurate to say that PQ dash here actually we calculated the size of this angle. We know that QM is perpendicular, therefore it is a straight line, and after we extended QM by a straight line, QP dash remains a straight line. So if we look on this side of this, the straight line QQ dash, the sum of the angles must be equal to 180 degrees according to rule number 1. So here 90 degrees plus the size of angle L must be equal to 180 degrees because of the fact that the sum of the angles on one side of the straight line QQ dash must be equal to 180 degrees. We subtracted 90 degrees from this equality, and we got that the size of angle L is 90 degrees. So this angle equals to 90 degrees. Okay, actually here, after we extended SR is the side of a quadrilateral, therefore it is a straight line. After we extended SR, that is a straight line by straight line, SM remains a straight line, and if we look on the bottom side of the straight line SM, the sum of the angles must be equal to 180 degrees. That is to say 65 degrees plus 50 degrees plus the size of this angle that we defined as Z must be equal to 180 degrees according to rule number 1. So here is subtracted 65 degrees and then 50 degrees from this equality, and we got that the size of angle Z equals to 65 degrees. So this angle equals to 65 degrees. Okay, then we focused on those two right triangles. The right triangle QRM and the right triangle QDES-RM, and we proved that those two right triangles can go into each other. First of all, we know that QM equals to QDES-M according to our construction, and we also know that those two angles are right angles, therefore they are equal to each other. That is to say, angle QMR equals to angle QDES-MR, and they are both equal to 90 degrees. And we also have a common side. RM is a common side, it belongs to both triangles, so RM equals to RM. So we actually proved that those two triangles can go into each other according to side angle side rule. We have two sides and the angle between them on triangle QDES-MR that corresponding equal to two sides and the angle between them on triangle QMR. Therefore, those two triangles can go into each other according to side angle side rule. And from the fact that those two triangles can go into each other, we first of all concluded that those two angles are equal to each other, and if this angle is 65 degrees, this angle will be also equal to 65 degrees. And the second thing that we concluded from the fact that those two triangles can go into each other is that RQ equals to RQDES. According to the rule that corresponding sides and congruent triangles are equal to each other. Okay, then we focused on those two right big triangles, triangle QMS, and the right big triangle, triangle QDES-MS, and we proved that those two right triangles can go into each other. First of all, we know that QM equals to QDES-M, according to our construction. Then we know that those two angles are equal to each other and they are both equal to 90 degrees. And we also have here a common side. SM is a common side, it belongs to both triangles, so SM equals to SM. It's a common side, so we actually proved that those two triangles can go into each other according to side angle side rule. Okay, those two triangles can go into each other according to side angle side rule, and from the fact that those two triangles can go into each other, we concluded that SQ equals to SQDES, and SQ equals to Y, so SQDES also equals to Y. Okay, so in the next step, we focused on triangle SRQ and on triangle SRQDES, and we actually proved that those two triangles also can go into each other. First of all, we know that RQ equals to RQDES, we have already proved it. We also know that SQ equals to SQDES, that's thing we have already proved. And SR is a common side, it belongs to both triangles, so SR equals to SR is a common side, so we actually proved that those two triangles can go into each other according to side rule. And from the fact that those two triangles can go into each other, we concluded that those two angles are equal to each other, so if this angle equals to theta, or if this angle equals to theta, then this angle will be also equal to theta because of the fact that those two angles are equal to each other. Okay, so in the next step we proved that line segment PQ dash is a straight line. We proved that line segment PQ dash is a straight line by proving that angle PRQ dash, if you look from the bottom side of angle PRQ dash, we proved that angle PRQ dash from the bottom side is angle that equals to 180 degrees. And indeed, what is the sum of the angles of PRQ dash from the bottom side? It is actually 50 degrees plus 65 degrees plus 65 degrees. It is actually 180 degrees. So from the fact that angle PRQ dash equals to 180 degrees, we concluded that line segment PRQ dash is a straight line, and if line segment PRQ dash is a straight line, then PQ dash is also a straight line. And from the fact that PQ dash is a straight line, we concluded that shape PSQ dash is a triangle. And in triangle PSQ dash, we know that PS equals to SQ dash, and both sides are equal to y, and we have the rule that in front of equal sides in the triangle there are equal angles. So those two sides are located in front of these two angles, therefore these two angles will be also equal to each other because they are located in front of equal sides, y and y. So if this angle is theta, then this angle will be also equal to theta. Okay, so we found out that those two angles are equal to theta, so from this point we continued according to what we did in method 1. So we have here two equal angles, both of them are equal to theta, and they are subtend on the same segment line SR. Therefore, according to rule number 2, the quadrilateral SRPQ is inscribed by a circle, and those 4 points S, R, P, and Q are located on that circle, or lie on that circle. Okay, here, because of the fact that those two angles are equal to each other and they are located on the same segment line SR, we concluded that quadrilateral SRPQ is inscribed by a circle, and points SRP and Q lie on this circle. And we have also rule number 2 that states that peripheral angles that subtend on the same segment line are equal to each other. We have angle X that subtend on chord PQ, and we have also angle PRQ that equals to 50 degrees that subtend on the same chord PQ. Therefore, according to rule number 2, those two angles that subtend on the same chord PQ are equal to each other. That is to say, angle X equals to 50 degrees. So we also found out that according to method 1, also the size of angle X according to method 2 also equals to 50 degrees. Okay? Thank you very much.